All right, we're going to continue our unit on polynomial equations by continuing our lessons on factoring. And so we're going to get into a skill for factoring called factoring by grouping. And I have these 5 factoring problems to kind of lead us into becoming really good at that particular skill, factoring by grouping. And we focus on the first 2. We're not really factoring those by grouping. What we are doing is getting used to seeing a greatest common factor that is actually a binomial. So if you look at numbers 1 and 2, the greatest common factor might look a little bit different. And so I'm going to work us into the concept of factoring by grouping by seeing if we can find a greatest common factor that looks a little bit different. So I'm going to start with an example that looks a lot like problem number 1. And hopefully it will help with factoring by grouping. So if I had an expression at 3xy minus 2y, and we were to use the methods that we're already good at with identifying the greatest common factor, we could see that in this expression, the greatest common factor is in fact that y. And then when we express that as a product, we would then divide out the y, and we would have y times 3x minus 2. And it would be easy to see that the y is the greatest common factor. And so now what I'm going to do is take the exact same example and write it a little bit differently. What if I took 3xy minus 2y and wrote it that way? Still, we'd be looking for the greatest common factor. And still, the greatest common factor would be the y. But it looks a little bit different. And so we're going to factor out that little bit different y and then express everything as a product. And so when we divide out that y, of course, we'll be left with 3x minus 2 again. And so you can see it's actually the same result, but it looks a little bit different. So now I'm going to train us to see the same thing. I'm going to write it a little bit differently again. So I'm going to take this exact same example and write it differently again. So what if we called it 3x times y minus 2 times y? Can you still see that the greatest common factor is y? And hopefully you do. It just looks a little bit different, and it's in a grouping symbol. So what we're going to do is factor out the y the same way we have done. The y is the greatest common factor, even though it's that crazy looking y. And we're going to express our whole thing as a product. And when we divide out that y from each term, we'll be left with, of course, 3x minus 2. So it doesn't change. It's just a matter, the process doesn't change. It's just a matter of seeing a greatest common factor that might look a little different. That's all. So the greatest common factor was easy to see as y in the first part of the example, but by the third one, it's still the same thing. It might look a little bit different. The process of factoring out the greatest common factor remains the same. And so we use that skill to help us with problems that look like number 1. Okay, so we look at the expression in number 1. And hopefully you see, now that we have done that little exercise, you can recognize that the greatest common factor looks a little bit different, that's all. It just happens to be in grouping symbols. And so we have our expression, and hopefully you can see that now the greatest common factor is the binomial x squared plus 5. And so what we can do then is completely factor out the x squared plus 5, and then express everything else as a product. What happens when we divide the x squared plus 5 from each term? We will be left with 3x and then minus 2. So we have divided out the x squared plus 5. Because if we look at the work shown, if we were to divide out x squared plus 5 from each term, we would see that it would cancel, leaving us with 3x minus 2. So the total expression is x squared plus 5 times 3x minus 2. That is how we express that problem number 1 as a product. So when we express this as a product of two things, we're looking at there. And so that is just a skill that we can use. So now we look at problem number 2. We're going to factor this by grouping, or we're going to identify the greatest common factor. So we're looking at the same skill. It's just it might look a little bit tricky. What will happen, we'll find out, because it's kind of neat. So we look at our expression number 2, and we can identify the greatest common factor. Hopefully you see that the greatest common factor is y minus 2. Hopefully you have noticed that. So how can we express what's going to be left as a product when we divide y minus 2? This is where things get tricky. So what will happen if we divide our first term by y minus 2, and what will happen if we divide our second term by y minus 2? Hopefully you see something that cannot be ignored. So what happens in the first term when we divide by y minus 2, clearly our y minus 2's cancel. It leaves us with x. And then in the second term, we have y minus 2 divided by y minus 2. What is anything divided by itself? 1. So it doesn't disappear. It turns into x plus 1. So a neat thing might happen when we're seeing binomials or polynomials as greatest common factors. Don't forget that anything divided by itself is 1. That is a key thing to remember. Remember, anything divided by itself is 1. Okay, so that's a key thing to remember. So when we successfully factor the second problem, we'll have as a product y minus 2 times x plus 1, and that's how we would get to the expression number 2. So now we have that skill down, right? So now we have that skill down. So what exactly is factoring by grouping? So when we have factoring by grouping, when we use this little skill set, factoring by grouping normally occurs when you're looking at something with 4 terms. And so if you see 4 terms, it's something you might want to try. And so factoring by grouping is basically taking a 4-term polynomial and then separating it into 2 terms. And then see if you can factor those. Separate into 2 terms. 2 groups, sorry, into 2 groups of 2 terms each. So if you have a 4-term polynomial, see if you can separate it into 2 groups. It's a separate, by the way. I know how to spell, I think. So separate into 2 groups and see what might happen. So let's take a look at number 3. All right, so we had AB plus 2A plus 5B plus 10. Okay, so we had our expression. There's a polynomial with 4 terms. Can we separate it into 2 groups? Okay, so see if we can factor that by grouping. So we'd have our first group, which would be AB plus 2A. And then our second group, which would be plus 5B plus 10. And the sign plus 5B plus 10 is going to be important. So please make a note of that. That is a plus 5B plus 10. I'm taking the sign with me. That's going to be important in a second. And so now what we can do is factor each group, right? So let's factor each group and see if we can factor using the greatest common factor method. So we're going to factor each group using the greatest common factor and see what happens. In the first group, hopefully you notice that the greatest common factor is going to be A. And then when we express that as a product, when we divide out A from each term, we'll be left with B plus 2. Hopefully you've seen that's, again, refresher course from the last lesson as well as the first part of this one. And now we look at the second group, and we have the greatest common factor of plus 5B plus 10. And hopefully you see that the greatest common factor is going to be 5. But notice, again, you've got to be careful with the sign. We're going to factor out a plus 5. Okay, so once again, we are being very careful with signs, and this will make sense in a little bit. So when I factor out plus 5 from each term in there, I'll be left with B plus 2. Okay, so now we have our expression a times b plus 2 plus 5 times b plus 2. So we have factored by grouping, right? But then what? Okay, but then what? And now we have to remember, do you see the greatest common factor in those two groups? Hopefully you see the greatest common factor in those two groups is that b plus 2. So exactly like we did with problem number 1 and number 2, we're going to do the same thing here. We will factor out the b plus 2 and express the remaining as a product. So if we divide out b plus 2 from here and then divide out b plus 2 from here, hopefully you see what will be left. If we divide out b plus 2, we'll be left with a and then plus 5. And that is factoring by grouping. So if this was confusing, what I ask you to do is hit pause here and rewind and make sure you pay attention to everything I'm saying and then hit pause or ask me questions. Okay, so if this was confusing, how we got to here, hit pause, rewind, listen carefully again because I talk a lot, and then hopefully it'll make some more sense. If not, then you're ready to go. Let's take a look at number 4. Okay, so now we can move on to number 4 and remember how the method works. So with number 4, we have an expression with 4 terms, and that is going to lead us to try factoring by grouping. Let's give that a try. Okay, so we're going to try this out. So we're going to try factoring by grouping, 4 terms, and we're going to group them into two different groups. So our first group, we would have 12xy minus 8x. And in our second group, we would have minus 15y plus 10. And remember, again, the signs. Okay, that's going to be kind of important. Okay, so we're going to factor those out by grouping and see what we can have. And so now we're going to do the greatest common factor method for each group and see if that helps us. Okay. So now we look in the first group, 12xy minus 8x. Hopefully you recognize the greatest common factor as 4x. And if you recognize the greatest common factor as 4x, we can then divide each of those terms by 4x. We will be left with 3y minus 2. Okay, so that's an important factoring piece. And now we move over to the second group. And in the second group, hopefully you see the greatest common factor of those two terms is going to be 5y, or excuse me, 5. So the greatest common factor is going to be 5, but let's be careful. We're going to factor out that negative 5 because here's where signs come into play very handy. Now we're going to divide each of these terms by a negative 5. And what's going to happen? What's going to happen is that we're left with 3y here and then minus 2 here. So it's important to pay attention to that sign in the middle because it makes a huge, huge difference. So here again is a time where you, if this was confusing, hit pause, rewind, listen carefully again because I talk a lot. But now we're going to continue factoring. Hopefully you see from here the greatest common factor is another funky looking greatest common factor, that binomial 3y minus 2. So now what we did in problems number 1 and 2 pay huge dividends. So we can see that the greatest common factor is 3y minus 2. We divide out, we'll be left with 4x minus 5. And we have now successfully factored by grouping. And so now one last example, and then we are good to go with factoring by grouping. The rest will be doing your homework and practicing. So now we're looking at number 5. And again, we have 4 terms, so we might want to give factoring by grouping a shot. Okay, so we're going to group the first 2, and then group the second 2, and we're going to be careful with signs. So we have our first 2 and our second 2, and we're going to be careful with signs. And from the first 2, hopefully you see that the greatest common factor is x squared. And so when we factor out our x squared, what will we be left with? X plus 1. And in the second group, hopefully you see that the greatest common factor is going to be a minus 4. Again, that sign goes with the term. That's going to be so, so important, as you can tell. And so when we factor out a minus 4, we'll be left with x, and negative divided by negative, positive. You see that? That's why it's so important to be careful with the sign. And now we see that the greatest common factor is a funky binomial. And we'll be left with x squared minus 4. Okay, so that's as factored as we can for now. We're actually not done, but we're done for today. Just a note, we'll factor this later. Note, we will factor x squared minus 4 later. Okay, so this is as good as we're going to go for now with factoring by grouping. Hopefully you learned that term. It's all about practice, practice, practice. And I'll catch up with you later. Bye-bye.